Are you interested in a career in web development or starting your own online business? If so, you need the right skills, and you need to learn them fast. Our web development course will take you from beginner to expert in building interactive, mobile-responsive web applications in no time. We teach you all the latest web scripting languages, including HTML, CSS, JavaScript, jQuery, Bootstrap, PHP, XML, and Ajax. You'll also learn to integrate MySQL databases into your web projects and administer them using PhpMyAdmin. Through a series of live demonstrations, you'll learn to build database-driven web applications, complete with member access areas, blogs, encrypted password authentication, and web-based input forms with Ajax and PHP validation. But that's not all. This course is unique in that it teaches you how to set up a solid, scalable infrastructure for hosting your web applications. Learn the benefits of using cloud servers over shared, VPS, and dedicated hosting. Learn firsthand how to create scalable virtual machines using providers like Linode, DigitalOcean, and Amazon EC2. You'll learn to scale your server configurations up and down depending on your needs, add hard disks, upgrade CPUs and RAM, create backups, and manage DNS. Control every aspect of your server. We demonstrate how to install powerful server configurations using LAMP stack for Ubuntu and handle administration using remote desktop connections, tight VNC, real VNC, and command lines. We'll show you how to do all this at a fraction of the cost of traditional hosting. You'll even learn to configure a server on your own local computer using WAMP or MAMP. Avoid having to scour through hundreds of YouTube videos and outdated website articles to piece together the web development puzzle. This will only leave you frustrated and discouraged. College courses and expensive online schools will drain your pockets and leave you in debt before you even get a foot through the door. We make learning simple. No redundancy, no time wastage, and no costly fees. Our lessons are right to the point, and we only use certified, experienced instructors. No long pauses, no distractions. Only clear, concise training material. Our course is well organized and easy to follow. Each module is accompanied with quizzes and assignments to ensure full comprehension of course content. We offer a 30-day money-back guarantee. If for any reason you are unsatisfied with the course, simply let us know and we'll reimburse you. You have access to fully qualified live support and direct access to the instructor online. Courses are updated regularly. So what are you waiting for? Register today. Start learning and get certified.
Welcome to the Web Development Masterclass. At this point, you've probably had an opportunity to look through the course outline and see this course covers an extensive amount of material. Don't let that overwhelm you. This course is designed to teach you just about every facet of the development process from beginning to end. Whether you're a beginner or a seasoned professional, this course will broaden your knowledge and inspire you to create stunning web applications. Yes, there are hundreds of books, YouTube videos, and articles on various aspects of web development freely available on the internet. This can certainly help you gain some insights into the field, but without putting it all into context, it can be very confusing and frustrating, especially if you're just starting out. That's why you'll find this course very useful. We start right from the basics, essential concepts that are fundamental in your ability to progress as a web developer and create complex web applications that interact with thousands of users. First, we'll start with an overview of how the internet works. What happens behind the scenes when you type a web address into your web browser? From there, we'll introduce the web development process and give you a detailed rundown of exactly how we'll go from setting up our local testing environment to hosting a live production web application on a fully scalable cloud server. Then we'll really kick it into high gear by diving into developing our own web applications with client-side development languages such as HTML, CSS, Bootstrap, JavaScript, and jQuery. Next, we'll work with database integration and server-side scripting languages such as PHP, MySQL, XML, and Ajax. All combined, these are the latest web technologies, and by the end of this course, you'll be more than proficient with each one. In the last module of this course, you'll employ all the skills you've acquired to build your own database-driven, responsive websites with encrypted password authentication, blogs, validated contacts forms, and much more. You'll have easily gained enough knowledge and hands-on experience to work as a web developer or even launch your own online business and start making money. We'll be walking you through step by step while we create over 12 website projects in this comprehensive course. Please remember to download the assignment and resource files so you'll have the necessary files for each lecture. Also remember to complete the lecture quizzes and exams to ensure you have effectively learned the course material. We hope you enjoy your journey through the course. Before we can venture into the world of web development, it's important to have a fundamental understanding of how the internet works. meaning what's happening behind the scenes when we type a web address into our web browser or send a file or email to a recipient. This information will be very useful as we explore the concepts covered in this course. To think of it in its simplest terms, the internet is a network of cables that facilitates the transmission of data packets. The network is extremely vast and spreads globally across 550,000 miles of hidden cables under the ocean to keep the world connected. This snapshot provides a graphical illustration of how complex the network of cables that power the internet really is. A data packet contains the information being transmitted, such as an email, file, or web page, in raw text format, and also the location of the sender and the recipient of the data packet. You can think of the location of a recipient or sender as the physical address of your residence or a phone number. No two residences have the same address, and no two people have the same phone number. The same is true for internet addresses, also known as an IP address. An IP is a string of numbers separated by periods that identifies each computer that is connected to a network or the internet. For example, the IP address for Google.com's web server is 74.125.224.72. Each website has its own unique IP address. We'll discuss how this IP translates into Google.com later in this lesson. Let's take a look at an example of an email data packet. As we can see here, the data packet consists of three parts. The header. The header identifies the sender and the receiver's IP address. It also specifies the protocol, which we will explore later on. It indicates the payload, which in this case includes the actual email that is being transmitted. Lastly, it includes a trailer, which indicates that the packet is complete and there is no further data for transmission. The speed at which these data packets can be transmitted over a network is determined by bandwidth. Bandwidth transmission capacity is measured by bitrate. The bitrate is the number of bits per second that a digital network can transmit. Another measure of data transmission speed is latency. This is the amount of time it takes for one bit to be sent from the sender to the receiver. Let's take a look at an example. If you want to send a 4 megabyte MP3 file to a friend through an email attachment in 4 seconds, you would require a bitrate of 8 megabytes per second. This is because 8 million bits equals 1 megabyte. Now, with billions of people connected to the internet at any given moment, it goes without saying that the internet is comprised of hundreds of thousands of networks and links billions of devices together globally. With this level of connectivity, you might be wondering how each individual network device can efficiently and accurately interpret and read data packets from various unique senders. Well, you can think of the internet as an architecture expressed in a set of protocols. A protocol is a well-established set of rules and standards used to communicate between machines. We've already touched on one protocol, the IP. The IP is used to route information to the proper address and make sure that the data packets are sent to the intended recipient. Note that the IP protocol does not facilitate physical connections between computers to transmit data packets. The TCP protocol is intended for that purpose. The TCP protocol makes sure that transmitted data packets are received without any missing information. If it's determined that the data packet is missing data, TCP will request that the sender resends them. Some other protocols that we'll explore in this course include HTTP, HTTPS, SMTP, and FTP. The HTTP and HTTPS protocols are very relevant to this course. These protocols define how your internet browser communicates with a web server to display your website. Keep in mind that a web page and its contents are transmitted in the form of data packets, just like any other type of file. You can think of a web server as a computer that hosts a website or web application and is configured to accept remote connections with internet users and relay data through the HTTP or HTTPS protocol. Note that HTTP stands for Hypertext Transfer Protocol, while HTTPS stands for Hypertext Transfer Protocol Secure. Let's start with taking a closer look at the HTTP protocol. When we type a web address into our web browser, so for example, www.google.com, our modem communicates with our internet service provider to translate this web address into a numerical IP address. This is done through DNS, Domain Name Servers. These are administered by our ISP, or Internet Service Provider. The domain name server is a list of domain names and their corresponding IP address. Sometimes your ISP may not be able to locate the IP in their DNS records. At this point, your ISP would take it a step further and query other authoritative DNS servers for the IP. Once the IP is found, it sends this data back to your web browser. Your web browser then sends a GET request to the IP address. And if the request is successful, the contents of the web page are delivered through data packets and displayed in your web browser. A GET request for www.google.com would look something like this: the HTTP protocol and the name of the host. This is the IP address for the google.com webpage. If the GET request is successful, google.com will send back packets with the HTML code for the home page. HTML is the programming language that instructs your web browser on how to present the page. It tells the browser where each object, text, images, videos, should be displayed and where they're located. What are SSL certificates? We'll begin our discussion by exploring how SSL certificates are used to secure communication and prove identity. SSL stands for Secure Socket Layer. An SSL certificate is a digital certificate that contains various data elements and encrypts information sent to the server using SSL technology. Since this definition can sound a bit confusing, let's simplify it using an example. Since an SSL certificate is a digital certificate, we can compare it with something most of us are likely familiar with: a traditional print certificate issued by some authority, perhaps a college or university. In this illustration, we can see that the certificate contains various fields. To start, we can see who has issued the certificate. In this example, XYZ University. Alternatively, if you went to another university, such as Harvard, the issuing authority would be Harvard. In the same context, an electronic certificate is also issued by an authority. By analyzing the data in a digital certificate, we can easily determine the issuing authority. Just like colleges and university certificates, SSL issuing authorities will have varying degrees of credibility. By conducting a simple internet search, we can see a large number of certificate authorities to choose from. The amount of information you need to provide in order to obtain a certificate will depend on the type of certificate you require. We'll discuss more on this later. On this Google search of SSL Certificate Authority, we can see a few well-known brands. We have DigiCert, GoDaddy, GlobalSign, Let's Encrypt, which we'll be working with quite a bit in this course. As you might guess, obtaining a certificate of graduation from Harvard would likely be harder than one issued by a local community college. The same is true for certificate authorities. Digital certificate authorities work the same way. It's up to the visitor of the web page to determine if they trust the body which has issued the certificate. Would you trust a certificate issued by Microsoft? Or on the contrary, would you trust a certificate issued by an unknown brand with a small internet footprint? Probably not.